Hello everyone, hope you're doing well. This shall be a last video on tidyR package video series. In this video, we will discuss on nest and unnest functions. We will build a linear model pipeline on mtcars dataset, and we will use same model iteratively on the subset of the data using the nest and unnest function and map function from the purrr package. So that's the plan. Without further ado, let's get started. Let's load the tidyverse package, and the dataset that I'm going to pull on is mtcars data. So this data has various car models along with the technical parameters. Now from this data, I am interested in looking at the relationship between the weight and the MPG. So how this relationship between the MPG, that means mileage of the vehicle, and the weight of the vehicle looks like. My common sense says that this relationship should be a negative relation. That means if the weight of the vehicle increases, then the mileage of the vehicle should reduce. Now I want to check this relationship with the help of scatter plot. Now in order to generate the scatter plot, I am going to use the ggplot function here, ggplot. This ggplot function is from ggplot to package. Now just to tell you briefly about ggplot to package, ggplot to package is one of the most important package from the tidyverse package system. So ggplot to package is created to make stunning data visualizations. So if you want to create the charts, the graphs, generate the data visualizations, then ggplot to package is a go-to package for you. And it is therefore highly recommended because visualization plays so much important role in any data analysis and modeling. That's why it is highly recommended to get a good solid understanding of this package. Now you don't have to look for another place though. I'm going to start a brand new video series right after I finish tidyR package series. So what I want you to do is simply subscribe to this channel and you will get notified on all the new videos on ggplot to package. So without further ado, hit that subscribe button, will you? Thank you. Now coming back to our discussion, I'm going to quickly show you how to generate the scatter plot. So here I will use the aesthetic function, and in aesthetic function you will have to tell what you want to plot on x-axis. Now in this case I want to plot weight on the x-axis and MPG value on the y-axis, and then I will use geom point. By the way, this plus sign is used to create different layers. You will learn that while we discuss the ggplot function. And finally, I'm going to use point as an aesthetic symbol to generate the graph. So if I run this, then I should get the decreasing trend as we would have expected. So we get the nice decreasing trend, which tells us that as the weight of the car increases, the mileage of the car decreases. Now we have some understanding of how the relationship between these two variables look like. Now let me now fit the model. Let me now fit the model for these two particular variables. So I'm going to create an object called model, and I'm going to use the lm function. Lm stands for linear model. Now I'm going to create a model between dependent variable and independent variable. Now in this case, my dependent variable is MPG because I want to check how the relationship looks like on the MPG, because I want to check the relationship between MPG and the weight, and the independent variable is the weight, right? And the data that I will be using is mtcars data. And finally, model. So let me run this and show you the model parameter. Here we go. It has given us the coefficient this coefficient minus 5.34 is telling us, what it is telling us, that if I increase the weight of a vehicle by say 1 ton, then I would expect the mileage of the vehicle would decrease by minus 5.34 miles per gallon. That's what it says. Now, if I want to further investigate different model parameters, then I can use summary function and pass on the model object into the summary function, and I get different model parameters. Now, as you can see, the output of this summary function is messy. It has lots of text and the numbers mixed together, so you really can't able to read it properly. You can't figure out which parameter is which. So I want to make this output in a tidy format. So in order to do that, we have a separate package called broom, B-R-O-O-M, broom, and in the broom package I am going to use the glance function, and I'm going to pass on the model to the glance function. And if I run this, then you can see that the output is now in a table format. So we get a nice structured table with each value and its parameter shown in a very structured way. Fine. Now it's the right time to show you the nest function. So far, what we have done, we have visualized the relationship between MPG and weight. Then we have created a model, a regression model, and we saw the different model parameters. The intention of this video is not to go through different model parameters, but to show you the use of nest and unnest function, and how these two nest and unnest function can be effectively used to generate the model pipeline. So now let me first show you how the output of nest function looks like on the mtcars data. So here is the output. Now you can see that. So let me use the view function. Yeah, now as you can see, the output is a simple list, and if I further drill down inside the list, I will get the table. So this table, this entire data set is encapsulated in the list, and that's what the output of the nest function is created. Now if I group this data, suppose if I group this data by a parameter called cylinder, so I will going to group this entire mtcars data into a small subgroups. Each subgroup will have the vehicles with the engine of that particular number of cylinders. So now if I do this, then you can see that I am getting 3 lists, each list for each particular type of engine. So I am getting a one list for engine with 6 cylinder, another for engine with 4 cylinder, and so on. And if I zoom in to the particular list, I will get all the vehicle parameters which have, say, 8-cylinder engine in this case. I'm sorry, 6-cylinder engine in this case. If I zoom in to another list, it will give me all the vehicles with the parameters which have 4-cylinder engine, and so on. So we just learned that the nest function will nest a subset of data frame based on some grouping variable, in this case cylinder, and the result is a list column, the data which has tables inside it. That's what we have learned. Now I want to run my model pipeline on all these 3 different lists. That means I want to create a separate linear model for each group. So what I'm going to do now is to show you how the one model pipeline can be recursively used for 3 different groups. So let me start with mtcars. So let me first copy this out, and here I am going to use the model pipeline that we have just built in. Okay, so let me first create a column called model fit. Okay, and then now I am going to use the map function from the purrr package. Now what this function will do, it will apply, this map function will apply a function to each table individually. So we are going to tell a map function to iterate over the data column. We saw this data column, which is a column of list. Iterate over the data column and apply a function that fits a linear model on each nested table. So we are going to use the lm function, and we are going to run the lm function on each nested table that we saw, and we are going to do this with the help of map function. The result we are going to store into a column called model fit. So that is what we will going to do. Now let's build up this pipeline brick by brick. So I will create a model underscore fit new column. Now I'm going to use purrr package, purrr, and map function from the purrr package. I'm going to pass on the data column. Remember, this is the data column. I'm going to pass on the same column into the map function, and here I'm going to write a function which will be lm function. We have used the lm function. In this case, the dependent variable will be mpg, independent variable will be weight, and data will be equal to df. Okay, so this is the first part. Now as we saw earlier, the output of the model fit function is not in a structured way, is in messy format. So we want to bring this output of lm function in a tidy, nice structured format. So I'm going to create another column called model output, and I'm going to use a map function again. In this case, we can apply the broom glance function on this fitted model, so that the output that we will be getting is in a more tidy format. So model output is the column that I'm creating. I am going to use map function again from the purrr package, and I'm going to pass on this model fit to the glance function from the broom package. Okay, and now let me view the output. Hopefully it should work. Yes, here we go. Now can you observe one thing? As we have just learned, the output of the nest function is always a list. So we got two columns here, model fit and model output, but the values of these two columns are the list. Right? Now we want to create a more simpler data structure. We want to create a table from this list. Now this is where a nest function comes into picture. So now what I am going to do here is I am going to unnest this model output, and let's now see what we get. So you can see that I have unnested the model output, and I have converted the list into a nice looking table, and that's exactly what we wanted. So in case if you have got lost, just to recapitulate whatever the things that we have done in this video, we have created a list using a nest function. We have grouped the data frame with some grouping variable, in this case cylinder. Each group value has its separate list, we saw that, and we got 3 separate lists for 3 separate grouping values. In this case, our grouping value is cylinder, so we got the 3 separate groups pertaining to 3 different engine types. Remember, each list has a tibble inside it because the output of the nest function is a list. So we got the tibbles. So we got, we got the output as a list, but each list has a tibble inside it. Then we train the linear regression model on each list using the map function from the purrr package. Using the map function, we could able to iterate the lm function on each tibble within a list. We could have done this because of the vectorized nature of the map function. Then we stored a map parameter in tidy format using a clans function from the broom package. And then the model parameters are stored as a list. We used unnest function in this case to convert the list back into a tibble. We started with the nest function. The output that we got is a list, and we wanted to come back to our original point where we have started. So we have to unnest everything that we have done, and finally we got our tibble. So we got 3 separate model parameters on 3 separate groups using one elegant data pipeline. So without the map function, without the nest function, without the unnest function, we would have to generate 3 separate data frames for 3 separate groups. We would then have to train the 3 different models on each group. That means that would have created a lot of redundancy in the code. That would have created a lot of repetition in the code. We could able to avoid everything with the help of the nest and unnest function, and all these 4 things together, the nest function, the lm function, the map function, we could able to elegantly use and create a beautiful data pipeline. That's what we have achieved in this video. If you like this video, do subscribe to my channel. Lots and lots of interesting videos to come. I will speak to you soon. Take care and goodbye.